one of the really key concepts in stoichiometry is being able to write balanced chemical equations. Now, what do we mean by a balanced chemical equation? It is, right, in a chemical equation we have our reactants, that'll be the things coming together before our arrow, and then our products on the right-hand side. In a balanced chemical equation, the number of atoms of each element are the same on both sides of the equation. And this is something that hopefully makes intuitive sense. The idea of this is that we don't lose any mass in the process of a chemical reaction. So if we have, say, 3 atoms of oxygen on our left-hand side of the equation, we should still have 3 atoms of oxygen on the right-hand side of the equation. They just may be formed into different combinations of molecules or ionic compounds. Same on both sides. And so one of the important skills as a chemist is to be able to take a chemical equation and make sure that it's balanced. Now, the way we do this is by adding coefficients before our compounds or our molecules that are reacting, to make sure that we know the proper ratio of our products and reactants that are involved in our chemical reaction. I think the best way to explain this is through an example. So let's go ahead and do an example from the book about and see how we go about this process. And so sometimes we'll be given a chemical equation just by being told the names of what's reacting. So here's an example. If you want to follow along in your textbook, this is sample example problem 3.10. So we want what's the equation, the balanced chemical equation for this reaction, for the reaction of dinitrogen pentoxide. This will also give us some practice with nomenclature. Oh, sorry, that's the product. So let me erase that. Reaction of nitrogen and oxygen to form dinitrogen pentoxide. Okay, so our first step is we want to write sort of like the bare bones basics of this equation. We know what the reactants are. Nitrogen and oxygen are reacting. Now, one thing to know about nitrogen and oxygen gas is that they naturally occur as diatomic molecules, meaning there are 2 atoms per molecule. If we go to the periodic table, which I should still have open here, there are several elements that we need to keep track of this for. When we're just told that nitrogen or hydrogen is present, we need to know that it's a diatomic. So if looking at the periodic table, the ones that we need to know this for are hydrogen, always occurs as a diatomic, not always, but mostly occurs as a diatomic molecule in nature as a gas. And pretty much all the gases except for the noble gases do this. So nitrogen, oxygen, fluorine, these also form as diatomic molecules, so N2, O2, F2, and then all of the, we don't need to worry about astatine because it's radioactive and super poisonous and you'll never have to deal with it, but all of the halogens, fluorine, chlorine, bromine, and iodine, occur as diatomics as well. Okay, so nitrogen, and that's something you'll become familiar with as we continue to practice with this. So we know that we're going to have, gotta get my pen back. We have nitrogen, and it's a gas. I'm not told it's not a gas, so we'll assume it's a gas. Oxygen, I'm going to leave some space there. It's also a gas. And then we need to interpret this chemical name that we have here, dinitrogen pentoxide. Di means 2, so we have N2, and pentoxide means we have 5 oxygens. And I happen to know this one's a gas. Oh, and it says in the example here that this is a gas phase reaction. So we know that everything is gases. Okay, now we have all of our products and reactants. We know what's involved in a chemical reaction. And I left some space here intentionally in front of each of these because we might need to add coefficients here to balance out the number of atoms. So let's look at each. So the second step is just to check, is this already balanced if we just write it as is? So how many nitrogens do we have on the reactant side? We have 2 nitrogens, and we have 2 nitrogens on this side. So the nitrogens are balanced. What about oxygen? We have 2 oxygens and 5 oxygens. So the oxygens are not balanced. Okay, so we're going to have to add coefficients here. Now, what's the simplest way to do this? Well, we need to get either 5 oxygens on the left-hand side, and generally we're not going to. Well, there are different ways to do this, but we can multiply this by 2 and this by 5, and so we can do a 5 here and a 2 here, which will give us 10 oxygens. In the process of doing that, now our nitrogens are no longer balanced. Okay, so our 2 nitrogens has now become 4 nitrogens. So to take care of that, we add a coefficient of 2 here. So now we double check that we have 4 nitrogens, 10 oxygens, and 4 nitrogens, 10 oxygens on both sides of the equation. And so this is a pretty simple example of how we can balance a chemical equation. And so the best way to learn this is through practice. We'll practice this in class, and you'll also get to practice this on your homework.